We are going to start by graphing the parent function, which is the square root of x. Okay? We're going to do that by making a table. Now, can I plug negative numbers into the square root function?
Yes. No.
Not to get real numbers, right? I can get imaginary answers, but that's not going to help me when I'm trying to graph on a real coordinate plane. So we have to use numbers that are not negative. So I cannot plug in negative numbers, but can we plug in 0? Yes. What is the square root of 0? 0. Can I plug in 1? What is the square root of 1? Can I plug in 2? I can. I don't get a whole number out. I get the square root of 2, which is about 1.4. I don't expect you to know that. Can I plug in 3? That's the square root of 3, which is about 1.7. Can I plug in 4? What do I get? 2. Okay. Now, what would be the next reasonable number to plug in that's going to give us a whole number out? 9. Okay. So we are going to skip these 2. There's no reason to put them on our graph. We can just use the whole numbers. So I'm going to graph 0, 0, 1, 1, 4, 2, and 9, 3. Now, if your graph is not big enough, like the graph on the homework tonight's not big enough to put 9 on there, you can stop with the 3 points, 0, 0, 1, 1, and 4, 2. And your square root function looks like this, which is like half of a parabola on its side, right? Which should make sense because the parabola is the inverse of the square root. Now, if I am asked to graph y equals the square root of x minus 3 plus 2, I'm going to use transformations to draw this graph. Can we describe this transformation? Horizontal right 3 and then up 2. So before I graph that, let's talk about the domain and range of the blue function. Since I can't plug in any numbers, any negative numbers, my domain is x's such that x is greater than or equal to 0. I can only plug in numbers 0 or greater. And my range is y values such that y's are greater than or equal to 0. I'm not going to get any negatives out of the square root function either. So when I take this function, the one I've circled in red, we are going to take the blue graph and move those 3 points. Which way? Right 3 and up 2. So I'm going to go 1, 2, 3, up 2. I'm going to go 1, 2, 3, up 2. And 1, oh, I forgot. This point here, it's hiding. Okay, so these are the points I shifted. And I'm not going to shift 9 because it's going to go off the graph. And my graph starts at that initial point and then goes to the right. Okay. So what would my domain for this red graph be? So let me erase some of all this in here. What do you think our domain is? The graph here. I took these 3 points from this graph, this table, And I move them each right 3 and up 2. This point, right 3, up 2. And then this last one, right 3, up 2. And now this graph starts at what value? What x value? 3. And it's greater than that, so my domain is x such that x is greater than or equal to 3 now. And my range, what y value? Is that 2 greater than 2? So y is greater than or equal to 2. Gosh. Now what if I'm asked to do plus 3 minus 4? Y equals negative square root of x plus 3 minus 4. Let's first describe the transformation. Horizontal, left 3. The negative is a reflection in the x-axis. And the minus 4 is down 4. So I'm going to put in a new coordinate plane here. So for these, we're going to start with 0, 0, 1, 1, and 4, 2. Those are the 4 3-points from our table that we made for the parent graph. And I'm going to move them all left 3. Then I'm going to reflect them in the x-axis. So left 3. So I'm going to move them all left 3. I'm going to mark it in red. There's left 3, right? Reflect in the x-axis. What happens if a point is on the x-axis? Stays, right? Where does the point negative 2, positive 1 go? Right. It flips over the axis, so it goes from positive 1 to negative 1. And this point flips and goes from positive 2 to negative 2. And now to get the final, I'm going to move these all down 4. And then I connect them. It doesn't go in both directions. It doesn't continue past that initial point. That's like a starting point. Well, because I showed every intermediate step. So the red dots are horizontal left 3. The pink dots are a reflection in the x-axis, and the black dots are final points down 4. So I didn't want to get lost in doing all 3 at once. Could you do all 3 at once? Absolutely. Yeah, but I wanted to make sure we really talked about what each of those looked like, especially for this example. So what's my domain? X such that x is greater than or equal to, because it's going this way. It's going towards numbers that are large. Greater than or equal to what number? Negative 3. My range, is my range going up or down? It's going down. So that means the range is y is less than or equal to what number? Negative 4. Notice that these numbers, h and k, end up in my form. Remember that y equals a square root of x minus h plus k. All that hk form is all the same. H comma K is where that graph is going to start. And then you move from there. Now, on the homework, we've asked you to graph something like y equals the square root of 1/2 x minus 2. Minus 5, sorry. Mm-hmm. Horizontal translation, right 5. And a horizontal stretch, factor of 2. But that's really hard to do. Yeah.
If the 1/2 was on the outside, do we still flip it or no?
No, with the one,
If it's on the outside, is it vertical stretch or
shrink.
shrink factor of 1/2?
Yes, if the 1/2 is on the outside, this is a vertical shrink
Okay. So it's opposite.
of 1/2.
It's the opposite of horizontal.
Yes. The horizontal is, or the vertical is exactly what the number is. It doesn't flip the number. Okay, so to do this, okay, we actually want to just make a table and plug some numbers in. Okay, so we're going to, because the horizontal stretch of 2 is kind of hard to do on the graph. I mean, we could, but it's kind of complicated. So at this point, we rather just take some numbers and plug it in. First thing I'm going to plug in is find where 1/2 x minus 5 is equal to 0. That's the starting point, where what's under the radical is equal to 0. We solve that by adding 5. X is equal to 5, 1/2 x is equal to 5. Multiply both sides by 2. And x is equal to 10. So my starting point is at 10, comma 0. How do I know it's 0? Because I'm not adding anything on the outside, right? If it was plus 2 on the outside, it would be 10, comma 2. If it was minus 3 on the outside, it would be 10, comma negative 3. Because this is 0, and then you're subtracting the 3, or you're adding the 2. Now I'm going to pick some numbers and plug them in. I want to pick even numbers so that I don't have a fraction, right? So I'm going to try 8. Okay, so we're picking even numbers because of the 1/2. If it was 1/3, we would pick every third number, okay? Just because we don't like to deal with fractions. So let's plug in x equals 8. The square root of 1/2 times 8 minus 5. Why am I picking a number smaller? What's wrong with this? It's negative, right? I picked a smaller number. That's not going to work for us, is it? Because it's going to be greater than. That's negative 1. That's I. That's not a good choice. How about 12? Let's plug in x equals 12. 1/2 times 12 minus 5. That's 6 minus 5, which is the square root of 1, which is 1. That's better. 12/1. Now what's the next even number? 14. So that would be 1/2 times 14 minus 5. 7 minus 5 is 2. I'm going to scrap that because it's not a perfect square. Right? Square root 2, but I don't want to deal with that. Do you think 16 is going to give us a perfect square? Do you think 18 is going to give us a perfect square? Let's try it. 1/2 times 18 minus 5. 9 minus 5 is 4. There we go. Square root of 4 is 2. So you kind of just go through the numbers and like, oh, that's not going to be a perfect square underneath. Skip. That's not going to be a perfect square. Skip. Oh, this one's a perfect square. I think I'll use this point. Okay? Now you can get strategic if you want and solve what's underneath the radical. When will this equal 4? When will this equal 1? Those are the numbers you want underneath. Or you could just kind of use trial and error. So we plug in 18 and we get 2. And then we plot those points. 10, 0. 12, 1.
You only need 3 points.
Yes. 12, 13, 14, 15, 16, 17, 18, 2. 3 points is pretty good. Draw your little curve. My domain is greater than 10. My range is greater than or equal to 0. Greater than or equal to on both.